can hear what I'm saying. Okay, so today we'll be talking about IIoT, make easy. So on behalf of TDS, I'd like to extend a very warm welcome to all of you. Thank you for allocating your time to attend this webinar. Okay, for our Q&A sections, we will be having it after our last speaker has spoken. So in case anyone were to have any questions, you may just type them inside our chat group and we'll answer it one by one at the end after our last speaker has spoken. Okay, and a kind reminder to all our audience. Okay, please remember to switch off your computer camera mode and mute your mic. Okay, in case any unnecessary noise or FaceTime image were to pop up during the webinar. So thank you for your cooperations. Before we move on to today's topic, okay, I'd like to introduce our company, new UVC mobile robots, okay, which have the technologies to kill virus and germs. Okay, and when the robot is not operating, you may use the top camera as a temperature reading, okay, of the people who is going in to your companies. Okay, it will alert if anyone has detected high in temperatures. I'd like to show you a video of how it's being operated.
UVC is a proven disinfectant against COVID-19 virus. Introducing UiBot, an anti-epidemic robot. Disinfecting your office during after office hours without the need for any human supervision. Scanning temperature of employees during office hours. With 6 UV lamps and a UV power of 180 watts, UiBot does a 360 degrees omnidirectional irradiation. Using shortwave UVC, UiBot is capable of destroying viruses' DNA and RNA in just minutes. Contacts us for more information.
Okay, thank you. Those who are interested in our UVC mobile robots, kindly just email to our tds@sales.com, okay, and we will send you more info about it. And for those who are not familiar with our TDS overall products, I have displayed up all the brands up here, as we are the authorized distributor for the following brands. Okay, so if you have any projects but you are unsure of which best product to choose, just speak to us, and we will guide you and we will guide you by choosing the best product for your applications. Okay, and for those who have missed our past webinar, not to worry. Okay, just subscribe to our TDS YouTube channel, and we will be uploading all our past recorded webinar. So do remember to click on subscribe. Okay. And lastly, for our next week webinar, we have invited speakers from a AMR company called Boxing Robotics. They focus on 3 main principles: flexible, collaborative, and infrastructure independent. They enable companies to adopt robotics automations with minimum changes to the infrastructure and adopt to their current operations. It can be deployed collaboratively with humans and machines around, such as forklift. Okay, and followed by our next speaker, Frederick from our company TDS, will be sharing on SCADA products called Simplicity. Okay, it helps provide true client-server visualizations and control from a single machine to plant locations. Okay, helping you managing your operations and improve decision making. Okay, thank you. That's all for me. Okay, so first I'd like to invite Taya from TDS. Okay, he'll be sharing an overview of HMS Flexi 205 by showing us how to log and transmit data to public clouds and customize dashboard. Hi Taya, are you ready?
Yes, Max. Thank you.
Thank you. I'm handing over to you now.
Okay, thank you. Hi everyone, my name is Taya. I'm application engineer from TDS Technology. Today I'm going to present about E1 VPN router called Flexi and its cloud service called Talk2M. And Flexi is a remote access with data communication. It helps you to connect your industrial equipment and collect the data and send it to your IoT application through the internet. Not only in your local network, but also anytime, anywhere, because it's a remote connection through our Talk2M cloud securely. So where is VPN? In this example, you are in the office. You can connect to your HMI or PLC from your PC, tablet or mobile directly because you are in the same network, same place. If you are not in the same network with your HMI or PLC, let's say you are at an overseas or home or branch office, you cannot connect to your HMI and PLC, the devices in your local office. So VPN is the solution for that. So when you install the VPN in between, you can connect to your HMI or PLC anytime, anywhere. You don't need to have to be in the same roof, same network. So our Flexi can do this VPN connection for you together with the Talk2M cloud. So here is the side-by-side comparison for you to understand clearly what is VPN. What can we do when we have remote access to an industrial equipment? We can remotely troubleshoot and program your PLC, view and control your HMIs, connect to an IP camera to check what is going on in your factory, and you can do technical support from your office. Connectivity is possible with all major PLC brands and their programming tools, including these brands. And it also can connect to robots like a universal robot, which is using Modbus protocol. When connectivity is established, you can get live with your automation devices, exactly as you are physically connected to it with a LAN cable. The benefits you can get with remote access. You can avoid unnecessary troubles, so it will reduce cost of traveling for you. And you can improve the customer experience by providing fast support in case of emergency. By improving the quality of the support tests and customer relations, it makes your engineers more efficient and committed to their job. It is important for a better work-life balance. And improve the overall performance of the equipment as there is maximum machine uptime and productivity. Flexi does include a full VPN connectivity solution with the Talk2M VPN service. When we talk about VPN, remote access, or cloud, we understand that security is the main concern. Security is our first priority. For this, Talk2M security is regularly audited and certified by third-party organizations. We have ISO certification, which shows that Talk2M is managed properly by HMS. in a very professional and secure way. And we also have STAR ISICOM certification, which is a cyber security certification, because TalkQM security is audited by an IT firm, which tries to hack the system to test the security. The E1 gateway establishes a secure outbound connection through TCP port 443, which is the same port that you might use to check your bank account or your emails. Therefore, no firewall setting requires to change, because this port is usually already open in the firewall. The LAN segregation ensures that a remote user can only access to device behind the E1 gateway and not to the rest of your factory network. The local user can easily keep control of the connectivity of the E1 gateway by connecting a key switch to its digital input. A detailed connection audit trail lists the whole history of connections and can be checked at any time by the administrator of the Talk2M account. Two-factor authentication is available to add lock-in security. As I mentioned before in previous slide, the security of the E1 solution is regularly audited by third-party security organization, and it is certified. These are the key features of Flexi. You can do data logging for your PLC data. You can monitor your live KPIs, key performance indicators, and you can create customized dashboard to monitor the machine real-time values. And you can get alarm notification via SMS or email. I'm going to show these features more detail in next slide. Data acquisition and logging. As previously mentioned, the E1 Flexi can read data from PLC. It supports all the main protocols. It can connect at the same time to several different PLCs and collect their data using different protocols. On the PLC side, there is no need to change any setting. So an E1 Flexi can easily be added to a machine which is already running to make it IIoT ready. To read the data from a PLC, some tags need to be created inside the Flexi. Each tag inside the Flexi will store the value of one PLC register. And the historical logging feature can be used to check the trend of the data in the past hours or days. This is my Flexi. I will log into my Flexi. Now I'm already inside my Flexi. These data are from your PLC or HMI or robot. So these are the data from your device that you input to your Flexi. I log historical data for OEE and temperature 1 in this example. So if I want to see the history, click on historical login table. Then choose the timestamp, then update. You can see your historical data. You can download these data as a text file. And you can see these historical data in graph view also. And you can see the real-time graph also. When you see the real-time graph, it will show you last 1 minute data. This is data acquisition and logging features. Key performance indicators. So local dashboards are a great way to monitor machine individually. But we also provide an easy way to monitor all your installation in one place. It is called Live KPIs features. In this feature, you can add up to 6 tags of Flexi as KPIs, which will make them visible directly on the Talk2M web portal called M2 Web. With this, you don't need to create anything by yourself to monitor your data. For KPI, you must create eCatcher account first. It's a free account. After that, go to m2web.talk2m.com and log in to your eCatcher account. In this M2 Web, you can see the data from your Flexi. And if your Flexi is already connected to internet and VPN, you can see it as online. When you expand it, you can see the data from your Flexi. These are the data in the Flexi. These are the data in Talk2M. So this is the live data from your Flexi. You can see the location of your Flexi device also. So this is live KPI features. E1 gateways are equipped with a web server. This web server can also be used to display custom HTML web page, showing important information about the health and production of your machine. We also provide a free software called ViewOn that helps you design your dashboard without programming. These local dashboards can be accessed from any web browser, even from a tablet or smartphone, through a local connection to the Flexi or through a secure Talk2M remote connection. And you can create dashboard in third-party cloud like Amazon, Azure, or IBM, and so on. If you want to use those public cloud, you need to write simple script to establish MQTT connection between Flexi and your public cloud. This is your customized dashboard. It's created with the software called ViewOn, which is a free software. You can create your own design like this. So these are the live data also from the Flexi. And this is a third-party cloud. Currently, we are using IBM Cloud. Just a different interface, same data. This is also the live data from your Flexi. So for the visualization, you can see your data through KPI, or you can create your own dashboard with view on, or you can send your data to your public cloud. All these visualizations are the browser-based, so you can access from anywhere through your PC, tablet, or mobile. The E1 Flexi Gateway can do programming using two different languages. One is basic scripting, which is relatively simple to use and enough for most of the programming needs. Another one is the Java programming. It's also possible for more advanced applications. A lot of programming resources and examples can be found on E1 Technical Forum and E1 website for developers. So for example, previously I mentioned that you can send your data to your public cloud using the MQTT connection. So you need to write the script for that MQTT connector here. That is one of the examples. Flexi can generate alarms based on the value of text to let you know when something happens on site. For example, send a notification by email or SMS when the level of water inside a tank reach 20% of its capacity. Then you can establish a secure connection to the Flexi to do a required action. Talk2M service includes a SMTP server, so you don't need to use your SMTP server, which means sending email notification to you from Talk2M email. It also offers SMS relay service. If you don't have a SIM card but you want to receive notification by SMS, it can be done with charges to your Talk2M account. Or you can just get a 4G extension card for Flexi, and then you can use your own SIM card for SMS notification. Now I'm going to show you email and SMS notification. How does it work? Now I'm looking at my KPI and my phone screen. I have set alarm for temperature 1. If temperature 1 is less than 10, I will receive a SMS and email notification. So I simulate my temperature 1 to make it less than 10. Then I receive SMS on my phone. This SMS template is customized. You can create your own template. And I will also receive email. This email template is also customized. You can adjust the template as you want. So this is email and SMS notification features. To summarize, Flexi is a VPN router for remote access. So all the features that I have mentioned here before can be used anytime, anywhere, not only in your local network or local office. And lastly, we are proud to mention that E1 devices are award-winning and certified remote access devices in the world. So if you are interested in this device, please make an inquiry to us and we are happy to help. That's all from my side. Thank you everyone. Have a good day.
Okay, thank you, Taya, for your presentations. Next, I'd like to welcome Mr. Isaac, okay, from Mitsubishi, to talk about how Smart Manufacturing Kaizen Level, they call it SMKL, can be utilized for IoT implementations, and also the different types of Mitsubishi products that can be used for IoT implementations. Mr. Isaac, I hand over to you now.
Hi, thank you, Max. Hi,
Welcome.
everyone. My name is Isaac, and I'm the Industrial Development Engineer from Mitsubishi Electric. So today I will be talking about the IIoT implementation with SMKL. Give me a second. Let me share my slides. Hi. Can everyone see the full screen?
Yes, Isaac, we can see it. Thank you.
Okay. So today the content that I will be talking about is firstly the overview of IIoT, Industrial Internet of Things. Second is about Smart Manufacturing Kaizen Level and what is SMKL. And also I will also share about some of our SMKL application example. And lastly is our e-factory starter package, the solution that we just launched recently to help the factory to implement IIoT. So I believe for IIoT, and most of you have listened all of these terms like AI, data analytics, machine learning, IoT, and some of you might even your boss ask you to implement IIoT. But saying it and implement a IoT system is totally a different story. So before that, let's do a very simple reality check. And with the study, it's actually shown that 85% of the business say that they understand the potential of Industry 4.0. And I believe if let's say you are doing sales and when you meet with your customer, and Industry 4.0 or IIoT is a very good topic to talk about. And in actual case, there is only 10 to 15% of the company or corporation, they have detailed strategy in place. And this is quite a pretty accurate figure from our experience in factory automations. Everyone heard about IIoT, and rarely they have a detailed strategy to roll out the exact plan on how to do it. And next, for predictive maintenance, statistic also showing that there is 87% of the people think that real-time data is very important, but only 9% can actually collect and manage the real-time data on their factory floor. And this data is from Central Europe, and even in Japan, there is less than 30% of the manufacturer in Japan can really see what is happening in their factory in real time. And from the graph here, from this circle chart here, we can see that the solid line is actually the reality, and thus the dotted line is actually the expectation. And there was always a very big gap in between where we are and where we wanted to get. And the shift from our reality towards our expectation has to be done step by step. And various aspects when putting in this program, we have to consider in terms of how we can increase the throughput, how we improve the OEE, and how we can improve the efficiencies. And let us go through some struggle from our customer. That's actually some of our real case study previously. And Firstly, some of our customers previously, they always said that they want to build a new Industry 4.0 production line. And they always come up with these terms like they want to build a full automation production lines with AI, machine learnings, digital twins, those cloud computing technology. And they are making a lot of bombastic terms. And to tell you the truth, when all of this technology been implemented, there will be always a lot of problems. Those proposals will be rejected. And why? It's because there is very high cost and low ROI. It probably takes 3 to 5 times that the boss was predicting, and it's a very tough job. The first time as the manager is talking to a lot of people that he has never to talk with, and he need to speak with IT vendors for software, cloud computing, networking, data scientists, and all of that is actually will be costing a lot. And reasonably, but very difficult. If let's say you look at a production line, if let's say it's very extremely complex, the calculation of ROI is also very, very difficult. How much we can really expect if let's say we implement this improvement plan. So at the end, everything is being rejected. Then another case study is actually the manager ordered the factory staff to do a data analytics projects with using AI. So when the factories start working on the injection machine lines, which have a lot of quality issue, they need to monitor the characteristic of machines like temperature, electric currents, motor data, to see when is the machine is going bad and start producing bad quality parts. And they put an edge computer on the machines to collect data in real time. As it is a very, very fast machine, they gather a lot of data, a bunch of huge database being collected, and they hired a data scientist on project basis to see if they can use the data to find out what is the problem. So the data scientists look at the data and try to find some correlation, try to find some trend, and did some testing with the actual machine. At the end, they can only predict 50% of the time when the machine would fail. But 50% prediction is considered quite low, which means another 50% they can't really predict the failure, and it will cause the failed product being manufactured. So at the end, this kind of accuracy of prediction is not good. And they spend few months, 3 to 6 months on this project using a lot of money. Then they need to start again to collect more data to improve the accuracy. And the next result is only 10% of improvement. So overall, it's only 60% of prediction rate. With this prediction rate, it's actually not doing much improvement, but at the same time, it costs a lot of time of the engineers, the cost, and the salary for the data scientists. So at the end, everything has to be ended, project postponed. Then they rather to spend the costs for the engineer to improve the productivity as more traditional methods. And for this IIoT implementation, there is a lot of different failure. Everyone said that IoT is easy and compatible with all machinery, but factory automation is a very complicated process. It's easy to say you want to put an additional sensor as a counter, but where to put the sensor and how to wire it is not that easy. Programming also required as well. A lot of people start energy saving projects, but at the end, they just get all the nice screen with all the histogram, pie chart, but not really save any data. They just find out how much energy they are using, and the overall view is like a very sophisticated and very bombastic visualization to feel that, wow, we are very, very advanced. And everyone talk about data analytics, but such as the case I told you is not magic. We have been trying to solve this problem for ages and never got the answer. Just if you pay money for AI and a data scientist, doesn't that you will get the return. So basically, these are the lessons learned throughout our experience dealing with different small SME corporation or even MNC. So we can dream big, but we always start small. I'm not saying that IIoT is a bad idea. We are a firm believer of technology that it will change the way we produce things. And this is why our company is continuing investing in IIoT e-factory for more than 17 years. And it is always important to dream big, to have a master idea of what you want to do in the future. And your factory will become what you dream of in a step-by-step matters. So next, simple KPI. One thing that is also very important to have everyone agree on the output of IIoT project that you are working on. So many times that I have seen management engineers disagree on the result of a project. Sometimes the thing that management level 1 and the engineer levels 1 is totally different. Then when you start a project, always set KPI that everyone agrees on and keep them very simple. Where, what level, and what direction. When are you always make your objective clear so that you can set your direction and also prepare the necessary resources for it. So I have talked a lot about IIoT, but next I would also show you SMKL, Smart Manufacturing Kaizen Level. This model is implemented and developed by Mitsubishi Electric in Japan. And the KPI we use for IIoT in manufacturing. And this is not a shortcut for going for your totally perfect IoT or Industry 4.0 factory. Everything goes in steps, and this is the map that we use to guide us through. And we have what we call Kaizen level and Kaizen areas. The Chinese word is actually 改善, and I will explain after this. And the key point is mapping and sharing within your organization where your area, where you want to go, and defining your KPI. For this KPI, for this SMKL, there's quite important terms that we are focusing, which is the maturity level. Okay, the maturity level basically divided into 4 stages: collect, visualize, analyze, and optimize. And another thing is the management level. The management level, so at here there is actually also 4 levels, from installation, workers, workshop, factory level, to the supply chain level. So the vertical is actually from collecting, visualizing, analyzing, and up to optimizing. And the horizontal level is actually how huge or how small the plan can be. From workshop level goes until up to the supply chain level. And let's say this is a very simple example of SMKL model that we've been implemented previously in our Japan assembly line. For instance, the direction that you should go for electronic assembly line is the optimization of the machine worker cell level itself at the step 1A, the red color square. Then you need to make sure that you collect, visualize, and analyze, then finally optimize the process of a cell level. And after that, you are sure that you can achieve the target ROI, then you can move on and going to more wider area towards workshop level, factory level, and even a supply chain level at the final stage. This is a sample that implemented in assembly line, but the journey might be different in case of energy saving. First, in a factory, it is important to understand where you are using most energy in your factory. Therefore, you would first take a big approach, trying to find out which production line is using the most energy. But finding out which production line uses the most energy will not save you any energy. You are just monitoring it. In order to save energy, you have to dig into the root problem. You have to find out in detail which machine uses the most energy. After you find out the root causes, then you will look into how you can improve the usage of energy in the specific machines, which is usually a mix of energy saving and production efficiency. So the path you will be going on will be different, totally different from an assembly line SMKL implementation model. And one other important aspect of SMKL is you should look at where you want to reach and also understand what knowledge your staff will need. In order to do this project, you will need a skill step outside of automations, knowledge about edge computing, AI, networking, cloud, and of course with connectivity always comes the issue of security as well. Unfortunately, issues with AIs and cloud are not only external issue now. With technology developing, I'm sure that AI and cloud will come down to PLC, network, and sensor level as well. So you might need to start to prepare your engineer, your staff for the age of IIoT implementations. The journey is not an easy journey, but as a manufacturer that has started a little faster than most companies, we today wanted to share what Mitsubishi Electric has learned in the past. And if you are interested, we do have a package solution to guide you step by step throughout the SMKL model, assisting you to reach the level that you would like to reach, to the more sophisticated system covering the entire production line and further. And next, I would like to go into some real life example as we and others company do use SMKL KPI in real life. So the first one is actually an application that about a manual motor assembly cell. In this case, what we wanted to improve is the efficiency of assembling a motor. In typical case, when we assemble motor, we would use drawing manuals from files and were not even monitoring the assembly line. And overall, we are just counting how many motor that we made at the end of the day. So our proposal was to install IIoT and utilize tablet and collect data to raise efficiency. And this is the actual screen. And you can see now the worker doesn't have to use paper anymore. And he just follows the instruction on the screen when assembling. And in addition, all the process are listed as well as how much time it took to complete each task is being recorded. When submitting the instruction, we also can calculate how much it would cost and how much we expected to benefit out of the project based on the past line out or working mistake. So it was an easy decision for the management to make it as the ROI was easy. And another sample project we did is actually about the final inspection process when we met electrical discharge wire cutting machines. Historically, for the final inspection, we were doing this by paper checking, those checklist style, and we wanted to change this to electronic formats. And this provided multiple benefits, as not only we were sure that the worker completed all the tests we did during the testing, and we also able to use this as a quality database and to save all photo data together. And when we ship out the products, when we have a quality issue, we can easily go back to this quality database and find out if we did have any issue in manufacturing. So overall, KPI ROI is the thing that everyone, every level should be agree on when you are going to implement an IIoT projects, and also have to forecast and foresee what are the stepping stones that you might be facing throughout the process, to map and to plan the action and check everything's using this SMKL model. And this SMKL is not only a Mitsubishi Electric initiative. We are now working with companies like Hitachi, Dassault System in working group, and also planning to propose this to ISO and IEC for standardization. And this is just a small part of introduction. We are preparing specific KPI, proposal worksheet, and flow sheets for this SMKL model. For those who are interested, can let us know. We actually have a white paper that have a detailed explanation of this SMKL model. And last but not least, these are the considered a quite new solution that Mitsubishi Electric has been launched recently, which we call e-factory starter package. And for this package, basically there's including hardware PLC, HMI, include the software ladder programming for PLC, and also HMI design page for our user to use. The visualization includes dashboarding, production counts, process capability index, operational status monitors, and also for maintenance wise, there is some cylinders, cycle time monitor, error inspections, and also some additional function, which is equipment trouble Pareto charts, control charts, and also lost time analysis. So with this, I will show you a very brief demo on the actual software. Give me a second. Hi, can you see my GT simulations?
Yes, we can see.
Okay, so this is the template, a standard template that we provided in our eFactory starter package. So there is dashboarding, production counting, all those different type of pages that our Japan site has been developed for our user to use it as a standard template. So give me a second. Okay. So for the dashboarding part, actually these are all the standard interface or standard visual that normally customer been using for all EE calculations or production count calculations. So let's say this is the pie chart here is actually non-operational factor. So if let's say there is any error occurred on these machines, the counter will slowly build up, and to let you know how efficient is the machine is. And also there is some product counting, product okay, you can see that the number of production increase. If let's say the NG product increase, the overall efficiency, the operating rate, the yield rate, all will be calculated automatically. Other than this dashboarding, for production count, actually at here, you can see that there is different type of product, different SKU, which our user can modify it according to their factory production lines. And also, you can do a lot of different type of product here. It will calculate everything automatically. What you need to do just to link the sensor data to the PLC level. And also there is another thing that we call process capability index. And give me a second, let me run the demo data. Okay, so this process capability index, basically there is a histogram that will calculate the product quality of your manufacturing parts. And because I'm demoing a good product data now, so everything is green. This CPK value, CPU value, CPL value. And the advantage of this template is actually you no need to know how to calculate all these things. The standard template in our PLC ladder program, it will calculate it automatically and come out with all these results. Then if let's say when I run the ng data, then this is the ng data that you can see that all this CPU value is actually slowly falling to below 1, and an error will be triggered if let's say it fall below 1. And the next one is actually operational status monitor. This is quite straightforward that most of the factory that they have currently, but they only using the tower light for visualization. Then at here is actually you are able to see how long is your machine is in stop status in a more visualization where that include all these bar charts. How long your machine is stops, how long your machine is operating, and also how long your machine is in idle or non-operating status. So all of this template is standard template, but you are able to do some modification to suit it into your actual production lines. So far, that's all for my presentations. Yeah, I would pass the mic back to Max.
Hi, thank you, Isaac, for your presentations. So it's finally Q&A time. So hi audience, if you have any questions, you may just type them into our chat room. Okay. Let's see. Okay, it seems like there's no questions for today. It seems okay, meaning it's pretty clear how simple our IoT device are. Okay. If not, thank you, ladies and gentlemen. We have come to an end for our webinar. Thank you very much for your participants. Okay, and I would like to thank you all speakers for your presentations. Thank you. I hope everyone enjoys the program. And if anyone has any questions, just email to us and we will approach to you individually. Okay, thank you, and I will see you on our next webinar. Goodbye.
Thank you, Max.
Thank you.
Thank you, Max.
Thank you, Isaac. Thank you. Bye.
Thank you.